Dear students, today I'm going to explain about what are the various advantages of using database management system approach and what is the history of database applications. This is the outline of today's presentation. Advantages of using DBMS approach, additional implications of using the database approach, history of database applications, and when not to use a DB, that is disadvantages of DBMS. First, we'll see advantages of using the database management system approach. The first and foremost application is controlling redundancy in the data storage. So, our college database itself, you will take the student information. Should, if you are using file processing system, means student information should be maintained in department, library, and office account session, three places. Okay, so the same data is stored in three different places. Data redundancy is there here. So here what is the drawback we are going to face means if particular student for address is changed means that may be changed in college department database but may not be changed in library and account session. So that will indicate produce duplication of data and wastage of storage and so on. So that should be avoided in database management system. In only one database system should be maintained for the student. Library, they want some information mean they can access from there. They can create the virtual table and they can access. Account people they can access, department they can access, and so on. So the controlling redundancy, that is the main advantage of database approach. And sharing of data among multiple users. More than one user can use the data at a time. Restricting unauthorized access to data. Unauthorized persons can't use the data. And providing persistent storage for program offsets. So this thing already you people have studied in C++ and Java, used in object-oriented programming languages. And providing storage structures for efficient query processing. Provide efficient storage structure for efficient query processing. Suppose we want to retrieve one particular data from a database, means it took more time for extracting the data, means it is not efficient. So it should use efficient data structure. I think already we have studied the different data structures: arrays, linked list, stack, queue, tree, graph, and so on. So it should use, based on the application, it should use efficient data structure to maintain the database, not to provide the efficient query processing. And providing backup and recovery services are very important one. Frequently the backup should be taken, not to lose the data. And recovery services required if any problem occurs, hardware or software problem occurs, that should be recovered. And providing multiple interfaces to different classes of users. Some user may be familiar with retrieving the data from the database through query. Okay, for example, retrieve I want this, select star from USN from the student. Some user may be familiar with the forms. Suppose for example you will go that online reservation system and all, we are going to get the form. That form we have to fill what our name and what are the details, the source, the train number, train name, and what is the source, place, destination place, date, and so on. This is called as form. Okay. And if we'll go for bank, suppose we want to know our account balance, means we'll tell to the data of bank clerk. They will check, they will give you your account number and they'll get extract the data. So it depends on the person, that interface is going to user, the interface is going to vary. That each user it is going to provide the different interfaces, representing complex relationships among the data and enforcing integrity constraints on the data. It should satisfy the constraints. Suppose for example bank means that minimum balance should be maintained for each account, SB account. So that and all constraints. Drawing inferences and action using rules. That is, we are going to study the things in triggers and assertions in the third module. So suppose for example we are having a department database. In the department table all faculty details, that is the salary of the total salary, and so everything should be maintained. If one employee left from the department, means the total salary should be updated. Okay, that should be taken care by using the rules. Okay, that will see in the third module. So these are main advantages. And the next is we are going to see additional implications of using database approaches. Potential for enforcing standards. It has to maintain the standard. For example, large organizations will take, they have to maintain the standards for to refer the data item names, display formats, screens, report structures. Everything should be uniform. They will maintain one standard for that. And reduced application development time. It should not take more time to develop the application. Then flexibility to change the data structure. Suppose today I have used the data structure for array to store the data. In future I want to change it to some other data structure. It should be that flexibility should be there. And availability of current information, up to date information should be there, otherwise the database is not a valid one. And the cost of the database should be affordable to manage. This is the various advantages of database system. Now we'll see what is the history of database applications. So first, in early days, we have used the hierarchical, and first we have used file systems. Afterward, hierarchical and network data models should be used to store the database. It is introduced in the mid of 1960s and dominated during the up to 1970s. The two data models is dominated: hierarchical data model and network data model. In the hierarchical data model, from name itself, it is that hierarchy should be maintained. It's like a parent-child relationship is used in the data model. And network data model, the graph-based structure should be used. Okay, that means in hierarchical, one-to-many relationships are there, but in network data model, all one-to-one, one-to-n, n-to-m, all that relationships should be maintained over there. Okay, still some of the applications in the worldwide, it is occurred using this, maintained using this hierarchical and network database management system. And next is now introduced in the 1970s, after that introduced the relational model, that will be introduced and researched and experimented by IBM research people, and other several universities also taken care for that relational model. So it is emerged in 1970s, it is started, and 80s it will be implemented. And then today what we are using, Microsoft database management systems, Microsoft Access, MySQL, everything is based on relational model. And then object oriented applications. In that object oriented applications, this is developed, the oriented data model is developed object after the object oriented programming is developed. So here this data model is mainly focus on the OOPS concepts like object, class and inheritance, polymorphism, encapsulation, and so on. These concepts are incorporated in the object oriented data model. It is introduced late 1980s and 1990s, when that object oriented programming languages are introduced. That time it is this model is developed. So for it is used for mainly for complex data processing in CAD and other applications. The relationship, complex relationship in order to represent means this data model should be used. Then after that, data on the web and e-commerce applications. We know web data, web contains the data in with HTML links, hypertext markup language with links, and among pages, database web pages should be created with HTML language. And nowadays that many that e-commerce applications are using this one, the HTML, and the latest trend is we are using XML, extended markup languages, taken compared to HTML. It is having more advantages compared to HTML. It will be used. And then extending database capabilities for new applications. Not only this, the scientific applications, the database management systems will be used. Image storage and management. Still now we know how the data will be stored. Now the image will be not to store. Image processing applications, we want to maintain store the image data. That how that image storage and management should be taken care. And audio and video data management. So in order to store the audio data and video data, we want to maintain that also taken care by the database management system. And data mining, we know that extracting the useful information from the database, that is called data mining, that plays a critical role nowadays. And spatial data management, we are having vast amount of spatial data that should be maintained. And time series and historical data management, weather data and daily sales information, these information should be maintained with the help of database management systems. So these are the history of database applications. In olden days, first we have used hierarchical and network model, next relational model, next object oriented. After development of the object oriented database, object oriented data model should be used. Then after that, e-commerce applications with the help of HTML and XML. Finally the database applications are extended to store audio video format, images and historical data, and spatial data management and so on. So we can't restrict that our database application is limited to one some particular thing. So nowadays everywhere, where to maintain the database management system should be used. And even these are the application advantages and applications of database systems. Even some drawbacks are there for using the database management system. So what is the main drawback of using the database management system is cost. So what is the what cost, how it is involved in the cost wise means, suppose any database management system we are implementing means, first we need initial investment cost is high, initial investment cost for hardware. So but not to implement that database system, we need to purchase this has to satisfy some hardware norms, this processor capability, RAM capability and so on. So hardware investment, and then software, buying that software, and the people we have to train, so the training, that cost is more. And overhead for providing generality, security, concurrency control and recovery integrity functions, it is very it is also involves more cost. Additional tools should be used for this purpose. So this is the main drawback of database management system. So what we can use, how we can rectify this problem means, suppose in some applications we want to use the database which is not changing frequently, means that is stringent database, it is not going to change frequently, means we can go for file management system. Okay, and then there are no need to multiple users are not sharing the database, means we can go for file processing system. So using this way we can avoid the database management system here. So this is the only drawback of database management system. I think people have understood this. Thank you.